Welcome to Lecture 2.2, Prime Numbers, Factors, and Reducing to Lowest Terms. So what's a prime number? You may have heard about prime numbers before, but here's what's so special about a prime number. It's any whole number greater than 1 and that has exactly two unique divisors, itself and 1. And we'll get more into that and how to describe what a prime number is. A divisor is a number which can divide another number evenly without a remainder. So 2 is a divisor of 4 because 2 goes into 4 twice, no remainders. 3 is a divisor of 51 because it goes into 51 17 times without a remainder. So here are a list of prime numbers, the first couple of prime numbers. 2 is very special because it's the only even prime number. 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, and they go on indefinitely. There are as many prime numbers out there as there are non-prime numbers. Non-prime numbers are composite numbers. They are any whole number greater than 1 that is not a prime number. Composite number always has at least one divisor other than itself and 1. Like 4. 4 is not a prime number because 4 can be divided by 1 as well as 4, but also 2. So it has at least one other divisor. So let's take a look at an example, and we want to identify each number as a prime number or a composite number. So for the composite numbers, let's give at least two divisors other than its the number and 1. 43. Well, 2 doesn't go into it because it ends in an odd number. 3 doesn't go into it evenly. 5 doesn't because it doesn't end with a 0 or a 5. 7, nope. 6, nope. 6 isn't prime. 11, no, not 11. 13, no. And I'm going to stop there. I'm pretty sure 43 is a prime number. But if you need to, you keep going and going. You may want to see the list of prime numbers and you say, no, 2 doesn't go into it. 3 doesn't go into it. And I stopped off at 13. 17, no. 19, 23, 29. Now it's just too big to go into it, so nope. Let's look at 12. Well, I'm pretty sure 12 is a composite. The reason being it's that it's greater than 2 and it's an even number. So I know that 6 times 2 will be 12, as well as 3 times 4. So it's definitely a composite number. 51. Let's see, 2 doesn't go into it, but 3 goes into it. So it is a composite. And it's 3 times 17. It does look like it could be prime, but it is not. 3 times 17 is 51. 100. Well, let's see. 11 times 10 is 110. Nope, 10 times 10. So let's see. 3 times something. No. 5 times something. No. Again, the trick about 5s is that is it divisible if it has a 5 or a 0 at the end. 7. No, because that would be 31 and 7 doesn't go into 11. No. 13. No. So I'm going to say it is prime. Okay. Now I just want to point out that every composite number can be written as a product of primes. For example, 51, 3 is a prime and 17 is a prime. 12, 3 is a prime, but 4 is not prime, but we can write 4 as 2 times 2. Okay. So it's 3 times 2 times 2, and those are all prime numbers. Now you might hear the word factor. Factor is the same as divisor. When you're looking at a fraction, remember that it's dividend divided by a divisor. The divisor can also be called a factor. Generally, factors, there are multiple factors in the divisor. Prime factorization is the process of writing a composite number as a product of its prime factors. For example, 12, the prime factorization is 3 times 2 times 2. Or you can also write it as 2 times 2 times 3. Okay, that is its prime factorization. You have gotten it all down to all of its primes. So let's break down 108 into a product of its primes. Well, I don't know off the top of my head, so I'm going to take it step by step. The first thing is, I know 2 goes into 108 because it's an even number. So it's 2 times 54. But I'm not done because 54 is not a prime number. I know that because it's an even number and 2 can go into it. So now I have 2 times 2 times 27. But 27 is not a prime number, so I can break down 27 even more. So it's 2 times 2 times 3 times 9, because 3 times 9 is 27. 3 is a prime number, but 9 is not, so I continue to break down the 9. So finally, 108 breaks down into 2 times 2 times 3 times 3 times 3, or 2 squared times 3 cubed. So let's do the same thing, and this time let's do it to the number 60. Okay. 60, I'm not too sure, but I do know a 2 times a 30 will give me 60, but 30 is not prime because, again, it's an even number, so 2 will go into it. This is my logic. You might see it otherwise, but 2. And then 30 breaks down into 2 times 15. But 15 is not prime. So I have 2 times 2 times, what does 15 break down into? 3 times 5. 3 is prime, 5 is prime, likewise 2 and 2. So the prime factorization for 60 is 2 squared times 3 times 5. Now that's not the only way to break 60 down into its prime factors. I'll still end up with the same thing. But let's say I start with 60, and instead of immediately seeing the 2, I said, oh, well, 60 is 6 times 10. Well, 6 is not prime, but I know that 6 can be broken down into 2 times 3, and 10 can be broken down into 2 times 5. Now I'm going to rewrite the numbers from the small to the large. 2 times 2 times 3 times 5, and then group the 2's together as 2 squared times 3 times 5. Same exact answer. Even though I broke it down a little different, I'll end up with the same exact answer. So the lowest terms is a fraction. A fraction is said to be in the lowest terms if the numerator and denominator have no factors in common other than the number 1. Okay, for example, fractions in lowest terms would be 1 over 2, 1 over 3, 3/3, 1/4, 3/4, 1/5, 2/5, 3/5, and 4/5. Those are all in its lowest terms. Fractions that are not in the lowest terms are 2 over 4, because they each have a 2 in common. 6 over 8, they both have a 2 in common. 10 over 15, they each have a 5 in common. 11 over 22, they both have an 11 in common. And 100 over 150, they both have a 50 in common. So to reduce 12/15 into its lowest terms, The first thing that I think it makes it a little bit easier is to break it down to each, the numerator and the denominator, to break them down into their prime factors, and then see what each has in common. For example, 12 breaks down into 2 times 6, and then 2 times 2 times 3. 15 breaks down into 3 times 5. But 3 over 3 is a 1. Remember that rule. Anything over itself is 1. So that can be reduced to 1. Now we're left with 2 times 2 on the top and 5 on the bottom, giving us 4/5. So let's try another one. 126 over 165. Let's break it down. 2 times 63. Okay, I'll just work with the numerator right now. 2 times, and 3 can go into 63. 3 times 21, and 2 times 3, and then 21 can be broken down into 3 times 7, and I'm done. Okay. In the denominator, I don't see a 2 can go into it, but I do know a 5 can go because it ends in a 5. So 5 times 15, that's 33. 33 can be broken down to 3 times 11. 5 times 3 times 11 are all primes. Okay. Now what do they both in common? They both, the numerator and the denominator both have a 3 in common. So now my final answer is 2 times 3 times 7 is 42, because 21 times 2 is 42, and then 5 times 11 is 55. Because I broke all the numbers down into its prime factors, I know for sure 42 over 55 is the lowest term for at least this particular fraction. Here's another example. Let's reduce the fraction negative 294 over 693. Reduce that to the lowest terms. Go ahead and pause the video and try it yourself, and then once you've tried it, come back and see what my solution is. Alrighty, here's my solution, negative 14 over 33. Why? Well, the negative I'm going to write as negative 1, and then 294 breaks down into negative 1 times 2 times 3 times 7 times 7. And 693 breaks down into 3 times 3 times 7 times 11. They both have a 3. The numerator and the denominator both have a 3 in common, as well as a 7 in common, leaving me with negative 1 times 2 times 7, negative 14 for the numerator, and 3 times 11, 33 for the denominator. I'm going to run through a problem pretty quickly. So, Laura's having a party. She puts 4 6-packs of diet soda in the cooler. At the end of the party, she finds only 4 sodas have been consumed. What fraction of are the sodas left? And write the answer in lowest terms. So the number of sodas is 4 times the 6-pack, so a total of 24 sodas. 4 sodas have been consumed. They were drunk. So we drank 4 over 24, but there are 20 over 24 sodas left. Now we need to reduce the 20 over 24 sodas left to its lowest term. So prime factors of 20 are 2 times 2 times 5. The prime factors of 24 are 2 times 2 times 2 times 3, leaving us 5 over 2 times 3, which is 6. So that's it for this lecture. So until next time, be seeing you.